Greetings everyone, and welcome to this video in my lecture series on binary, octal, and hexadecimal numbers. In this video, we will convert non-integer decimals to other bases, and in particular, we're going to look at the case where the number in the other base is a repeating fraction. I don't want to call it a decimal here because in other bases you don't have decimals. So we're going to look first at converting, as our first example, we're going to convert 0.1 in base 10. You can see that there's no subscript, so this is a decimal number, to the binary number system. We're going to use the method of repeat multiplication, and so we're first going to write 0.1, and we're going to multiply it by the base that we're converting to, so we're converting to binary in this instance, so we'll be multiplying by 2. And we're going to separate our answer into the integer part and also the fractional part. I suppose here you could still call it the decimal part because we are still writing as decimal numbers, so it's going to be 0 plus 0.2. Because when we take 0.1 and multiply by 2, we get 0.2. There's no integer part, so that part is 0. Then we take, let me write that a little bit more clearly. Then we take the fractional part, or I guess this decimal part we can still call it, and we write it over here. And we say that 0.2 times 2, we continue to repeat multiplying by the base, gives us 0.4, so we're going to write that as 0 plus 0.4. If we then take the 0.4 and write it below and multiply it by 2, we get 0.8. Placing the 0.8 here and multiplying it by 2, this is the first instance where we actually have an integer part. 0.8 times 2 is 1.6. We're going to split that into two parts, the integer part and the fractional part. Then we're going to take the 0.6, multiply it by 2. This gives us 1.2, and we write this as 1 plus 0.2. Now, if you're careful, you'll notice that now that we've got the 0.2, if we were to continue on, we're going to get repetition, and it's going to be the same as if we went up and repeated the step again. Now, if that's not clear, then I think the best way to explain it is to just do it a little bit more, which is then 0.2 times 2 is equal to 0 plus 0.4. 0.4 times 2 is equal to 0 plus 0.8. 0.8 times 2 is equal to 1 plus 0.6. 0.6 times 2 is equal to 1 plus 0.2. And look, we have repeated exactly the same thing as we had before, that we're now once again at 0.2, 0.2. This fractional part is never going to go to 0. It's just simply going to repeat. Now, if you take a look at the integer part then here, that I have now highlighted, you'll notice that the pattern that is repeating here does not include the first digit. It goes from 0, the part that is repeating, I'm going to highlight by writing, drawing a circle around it, that when we have the 0.2, if we were to just consider that we're going back up to the top, the part that's repeating is the part that is in all the lines that we would be going back to. So, or a different way to look at it is this 0.2 is going to head on over up to that position there. So it's 0.11 that's repeating. And so our answer then, and let's actually just write out what I've just said, which is this is going to be a repeating pattern since the non-integer part the fractional part here, or the decimal, I suppose, will never go to 0. It will simply go back to 0.2, and you'll start at that pattern again. So in conclusion, we're going to write the 0.1, and to really hammer it home what we're doing, this is 0.1 base 10, the decimal system, is going to be 0.0, so that's that first 0 that we can see. And then the repeating part, we're going to place under the repeater bar 0, 0, 1, 1. And it's all binary, and it's base 2. Okay, so that's our video for today. Thank you for watching, and I hope to see you in the next video.